Hi, TFA. So, as promised, there is no homework tonight beyond you listening to this screencast and taking notes on it. Now, I will say this. When you listen to the screencast and take notes on it, I do ask that you do this in a way that it's active, that you're not just kind of blindly copying this down. Because what I will start with tomorrow in class, tomorrow being Tuesday, is asking you to, I'll be asking you questions and I'll be assessing based on your answers kind of what your comprehension of this screencast was, okay? So we are going to talk about functions more, okay? We've been talking about functions a great deal, talking about transforming functions, moving them left, right, up and down, reflections, scale changes, stretches, shrinks, all of that. What we're going to talk about today is if you're given a function, what is the inverse of a function? Okay, so what does it mean to find the inverse of a function? So some notational things first, okay? When you want to notate the inverse of f of x, okay, the inverse of f of x we write this way. We write as the inverse of f of x, f of negative 1 of x. Be very careful here. This negative 1 is not an exponent. This is just a way of saying the inverse of f, okay? Similarly, if we want to talk about the inverse of a function, let's call it g of x, we can say the inverse of g of x written out in words this way, or we can write this as the inverse of g of x, okay? So notationally, you know now how to write the inverse of f of x, okay? All right, so when we talk about a function and its inverse, first let's talk about this from a graphical perspective. So what I'm going to ask you to do here is to come along with me and let's do this. Let's go ahead on some graph paper, and I see that you see that I have some graph paper here, and I'm going to do this. I'm going to graph this function right here. I know what I'll do. I will graph, let's graph the parent square root function. Okay, so right here, this is the parent square root function. This is f of x. Okay, I'm not going to actually write the square root of x here. I'm just going to call this f of x. When we talk about the inverse of f of x, let's write this down first. Graphically, the inverse of f is the reflection of f of x over, okay, now let's think about this. We've talked about reflecting functions before. We've talked about reflecting a function over the x-axis and over the y-axis. But in the case of functions and their inverse, the inverse of a function is the reflection of f of x over a particular line, and that line is y equals x. So this is a really important point, okay? What does it mean graphically for a function, for a function's inverse to exist? Now, what I'm going to do here is, and I'm going to ask you to do the same thing, I'm just going to go over here and kind of dot in the line y equals x, okay? Here is the line y equals x. This is the line y equals x. And as in all cases, right, if you actually listen to this screencast and take the notes down in a really mindful, active way, you get a whole lot more out of it. And frankly, in the end, you end up causing yourself less work and less time in the future because your first run through it was mentally invested. What I want you to do, boys and girls, is, assuming you did this on your notebook paper, go ahead and fold your paper along the line y equals x here. And when you fold your paper along the line y equals x, tell me where that brings f of x. In other words, what happens to f of x if you reflect it over the line y equals x. So fold your paper along the line y equals x and see if you can see where f of x goes. And I'm just going to go ahead and label these points here on f of x, okay? And pause me, and then go ahead and do that investigation. All right, I'm going to take a guess here and say that when you did that exercise and you folded your paper along the line y equals x, your graph, look at my pencil tip, of f of x, which was here, ended up looking like this, okay? So the point 0, 0 stayed where it was, and 1, 1, since it's actually on the line of reflection, didn't move anywhere either. So once again, 0, 0, and 1, 1, because they fell on the line of reflection, stayed where they are. 4, 2 went over to 2, comma 4. And what happens graphically is that, right? Here is the inverse of f. Look at that. So graphically, how do you know, or what is the relationship between a function and its inverse graphically? Well, one way of thinking about that relationship is the fact that f and its inverse are reflection symmetric, okay, or they're reflection images of each other over the line y equals x. That's better. F and its inverse are reflection images over the line y equals x. Okay, so this is really, really important, point number 1. What do you notice too here, girls? So girls and boys and girls, sorry. Sometimes I have to stop my habit of saying girls because I came from an all-girls school. It's still a habit that I'm undoing. I'm going to go over here to the inverse and graph 0, 0, 1, 1. 4, 2, we said became 2, 4, right? Okay. I'm going to do a couple of things here. Let's just by observation. Let's do this. I want you to find the domain and range for the inverse of f and for f. Okay. So let's go over here and do the domain and the range. Let's do interval notation. Why not? For both f and inverse of f. Okay. All right. Well, for the domain of f of x, the domain of f of x is x such that x is 0 to positive infinity non-inclusive. The range is y such that y is 0 to positive infinity not inclusive. Okay. The inverse has a domain. Oh, interesting. The domain is 0 to positive infinity, not inclusive. The range here is 0 to positive infinity, not inclusive. And here is the beauty of these screencasts. If someone looked just at this table here, they may mistakenly say, oh, for a function and its inverse, they will always have the same domains and the same range. And while that's true of this relationship, is that always the case? Let's see. Example number 2. Come on down with me. Okay, now I'm going to just sketch this picture. Okay, and I'm now going to make up kind of a nonsense function. Okay, let's see. Let's make a nonsense function that looks like this. Here is f. It passes to the point -2, -3, 0, 0, 2, 1, and oh, I don't know. Okay, so okay, this is the point 4, comma 2. This is 2, comma 1. This is 0, 0, and this is -2, -3. Okay, let's just call this function here f of x. All right, and let's see. Let's go ahead and put in dotted that line y equals x, because we know this function will have an inverse that is its reflection image over the line y equals x, right? Y equals x. Okay. Now, again, you can kind of do the paper folding exercise, or you can kind of see here, if I take f of x and reflect it over the line y equals x, let's go ahead and put in the inverse function. Let's see. Well, 4, 2 is going to become 2, 4. Okay. 2, 1 becomes 1, 2. 0, 0 stays where it is. Negative 2, negative 3 becomes negative 3, negative 2. And I know it's going to be maybe a little bit snug on your paper. All right, look at that. And this is the inverse. So we said graphically, a function and its inverse are reflection images of each other over the line y equals x. Okay, let's go over here and do the exact same exercise for f of x and for the inverse. And let's see if we can come up with a generalization. Let's take a look at the domain of both and the range of both. Okay, interval notation. Go ahead and do this one on your own and then replay me for the result. So I want the domain and range of both the function of x and the inverse of f in interval notation. Okay, so for the function, the domain, again, is a set of x values represented. I've got negative 2 to 4. The range of f of x is from negative 3 to 2, inclusive. All right, the inverse of f's domain. Inverse of f's domain is, oops, I should label these points, shouldn't I? Let's see, this point here was 1, 2. This point here was negative 3, negative 2. All right. Domain of the inverse of f is negative 3 to 2. The range of the inverse of f is negative 2 to 4. All right. Now, I'm hoping that you're seeing some connections here, but we know when we talk about a function and its inverse, graphically, graphical perspective first, right? We're talking about graphical perspective. Graphically, f and its inverse are reflection images of each other over the line y equals x. I'd probably call this like point number 1, okay? There are 2 other points related to that. The second point you notice is, notice something here, boys and girls. The point 4, 2 on f of x corresponds to 2, 4 on the inverse, right? And I know with 1, 1 corresponding to 1, 1 and 0, 0 corresponding to 0, 0, you don't see explicitly how x, y becomes y, x. But look at this example over here. 4, 2 corresponds to 2, 4. 2, 1 corresponds to 1, 2. Negative 2, negative 3 corresponds to negative 3, negative 2. So the second point is that the point, any point, let's call it x, y, on the function corresponds to, and when we say corresponds to, we're saying that the reflection image of that point on f of x, when you reflect it over the line y equals x, it corresponds to y comma x on the inverse, okay? This is just the formal way of saying, look, notice the x and y coordinates reverse between a point on the function and a point on the inverse, okay? Related to this, what do you notice? The domain of the function becomes the range of the inverse, and the range of the function becomes the domain of the inverse. And a lot of times when I've taught this lesson, students say, basically, Ms. Yam, is it true that all the things that are true of x for the function are true of y for the inverse? And the answer is yes. That's exactly it. So related, the point 3 here, that should be a 3. Okay, the third point that's related, all these 3 points are related. Okay, the third point is the following, that the domain of f of x, okay, corresponds to the range of the inverse, okay? And similarly, right, the range of f of x corresponds to the domain of the inverse of f. Okay, so this screencast is really about just introducing you to some new terminology, what it means to be the inverse of a function, and we've talked today about what it means graphically to be the inverse of f, okay? And now the first example here, if you look at the domain and range of f and the domain and range of the inverse of f, it may look like to the casual observer that, oh, the domain and range of f and the inverse of f are the same. And while that's true, yes, I want you to understand that what is still happening here is that the domain of f is still the range of the inverse, and the range of f is still the domain of the inverse. Okay? All right, that is it for homework tonight as promised. Tomorrow, Tuesday, when I see you, we'll be doing an in-class problem set on this screencast of functions and its inverse, and we will build from there. All right? Have a good evening, everyone.